Good afternoon. My name is Emma Joseph, and for the past 3 weeks, I've been a member of the Rex Computational Science program with Mr. Gottwals. I'm also a member of the NCSEM online program. For the purposes of this project, I wanted to see how I could use quantitative cell nuclei data to help hypothesize breast cancer diagnosis within patients using machine learning. The idea for this project had come from a previous project that I did in another computational science class that I took last year. For this project, I had found a dataset from the UCI Machine Learning Repository that had a bunch of different quantitative data about cell nuclei, including aspects like the size of the nuclei, the smoothness of the nuclei, and a lot of other different features, as well as a resultant diagnosis for that cell, where the cell was either benign, it didn't have cancer, or malignant, it did have cancer. So I wanted to see which features from this data gave the biggest clues as to what a resultant diagnosis of a cell would be. So in order to do that, I generated a bunch of different graphs through Mathematica, which you can see to the left, that essentially what I did was I looked to see where the overlap was for each feature. So yellow was malignant cases and blue was benign cases. I wanted to see where the least amount of overlap was to see which features were the most significant and use that to kind of model the project that I would do in this class, which was creating a machine learning program that could take in the most important data points of a cell nuclei and give a predicted diagnosis. So when I did that, what I had gotten were from these graphs were that the most significant features were, in fact, the radius of the cell, the perimeter of the cell, the area of the cell, and the severity of concave portions on the cell. So I would use those four features to develop my model that I would develop in this program. So this entire project falls under the branch of computational biology or bioinformatics, which is essentially using data and software to learn more about biology. For this project, I first focused on analyzing all of my Mathematica graphs to figure out which features were going to be the most important and developing the model that I would go on to create. And then finally, when I got into the whole machine learning aspect of it, I wanted to figure out which type of machine learning model would be the most useful for my project. So since my project included putting in a bunch of input and then getting the output, which would be the predicted diagnosis, I went with a linear regression model. For this project, I first used Mathematica to help generate all of those graphs and figure out which features I wanted to use. And then I used RStudio to help design the interface of the model, which you can see at the bottom left. And I also used Python through Jupyter Notebook to train and test my model. This code was also developed with the help of ChatGPT to kind of help me learn more about what machine learning is and how it works. And I also ran this entire app through the terminal on my Mac. So when you look at the bottom left there, as I said, you can see the interface for this entire model. So it has different places where you can input all of the important data. And then when you go and hit that submit button at the bottom left, it gives you a predicted diagnosis of the cell based on whatever parameters you put into the model. And so after running this whole model, training it, I did run a thing to get a bunch of information about the model, and from that I saw that the model had a 92% accuracy and a 0.89 F1 score. So while the model was fairly accurate, there is obviously a lot of room for improvement, which is something I would want to focus on in the future. So these are all my references, and I would also like to extend an additional thank you to the Burroughs Welcome Fund and NCSM Foundation, as well as all of these people listed on the screen for helping make this project possible. Thank you.